Now, evaluate logarithm of 16 to the base 2. So how can we evaluate this? How can we get the result of this? Now, step by step, let's go. Let us call logarithm to the base of 2 of number 16, or logarithm of 16 to the base of 2. Let's call this as y. So our result is y. So let's say this is y. So our question is find y. And then we say that by using the logarithm, the exponential numbers and the logarithm relation, we can say that 2 to the power of y is equal to 16. So one more time, a to the power of b, if is equal to c, we can say that b is equal to logarithm of c to the base a. By using this information, what can I say? Here I have y is equal to logarithm to 16, okay? So how can I write this side? How can I write this side? So this base, you see now here, a, and still it is base here. So since my base is 2, I will write 2. And then these numbers c in the logarithm, which is 16, it's here now result. So I will say this is now result 16. And then here, result of the logarithm, which is b, is now exponent here. So the result of this logarithm is y. Now this is now exponent here. Now 2 to the power of y is equal to 16, I can say. So it is here. And then I know that 16 could be expressed as 2 to the power of 4. 2 times 2 times 2 times 2. So we know the exponential rules. When the bases are equal to each other, exponents are directly equal to each other. So y is equal to 4. That's it. Let me show you here on the PowerPoint also. How is the solution step by step? Yeah, it's directly write the answer. So y is equal to 4. Answer is 4. But when I give you some rules, directly we will solve also question without using this. I will say this is equal to logarithm, and this is equal to this, and this is 1, so result is 4, okay? Later I will give this rule, but right now, by using the definition, so definition is, one more time, let me explain. Logarithm of 16 to the base 2, if I call y or x, whatever you want, okay? It's not important. Even you can call x, even you can call y. Let's call y. If and only, just have a look, please. Just have a look. Take this number, put it here directly, and think like that, 2 to the power of y. 2 to the power of y. Understand? 2 to the power of y is equal to 16. So 16 means 2 to the power of 4, which is 2 to the power of y. So 4 is equal to y finished. That's it. For example, let me ask one of you. If I say logarithm 3 to 9 is equal to 2, how can I write this? Or let me say not 2, let's say y. How can I write this?
3 to the power of
9 equals, right? 9 equals 3 to the power of y. That's it. 9 equals 3 to the power of y. And then 9 means 3 to 2. It means that y is equal to 2. Examples are coming. Okay, let's go now. This example, I will use the same thing. So let me do this. Please have a look. Let's go, this is equal to y. This result is equal to y. So our problem is finding y. Now, logarithm to the base 5, 1 over 125 is equal to y means, have a look to the screen. Directly take this number and it is equal to 5 to the power of y. So 1 over 125 is equal to 5 to the power of y. Do you have any question? This is the definition. And 1 over 125 means 1 over 5 to the power of 3. It means that 5 to the power of negative 3. We should know the properties. How was the 1 over a to n means a to negative n, or a to negative n means 1 over a to n. Like, let's say 2 over negative 5. What does it mean? 1 over 2 to the power of 5. So if you have this, you can write this. If you have this, you can write that. So what will be then? Instead of 1 over 1 to 5, we will say 5 to negative 3. So this is equal to 5 to y. So it's clear that if and only if negative 3 is equal to y. That's it. We solved the question. Have a look. Now, let us see the solution in our book quickly. How is it? Okay, let's go y. And then 5 to y is equal to these results. Okay. And then 1 over 1 to 5 could be written as this form. It's okay. And y comes out negative 3, and it is finished. Now, what about this? So I'm writing logarithm to the base of 3 of 1 over 27. Let's call y. If and only if this number equals 3 to the power of y. 3 to the power of y. Till here, do you have any question? I think there's no
No.
question. This is simple. And 27 means 1 over 3 to the power of 3, which is 3 to y. So this means 3 to negative 3 is equal to 3 to y. So y is equal to negative 3. So we solve the question. So answer of this question is negative 3. Now, let's see. Let me clean this. What's going on? Yeah, it is here. So the result is coming to negative 3. Now, what about this? When you learn the properties later, the result is directly 1. Why directly 1? 17, 17. There is one rule. Logarithm of a to a is equal to 1. So 17, 17, 1, 15, 15, 1, 20, 21. But now we don't know the rule. So what can I say? Logarithm 17, 17 is equal to y. So by using the rules, so 17 equals 17 to the power of y. And so it's clear that 17 means 17 to the power of 1. So 1 is equal to y. Result of the question is 1. Okay? Now, it's your turn. Please use the chat screen. What could it be? Answer A, B, C, D. Okay? You can answer. You did directly? MashaAllah. Very good. Okay, so Ayşe, Şaza, Safiye, Zehra, Hanin, Melek, Büşra, Sonia. Everyone says C. Okay, the result is C. Let's see what is the result. Result is C. Excellent. So I don't need to explain. Now let's continue. Till here, we finish. Now, right now, b is greater than 0, b is different than 1, and x is a real number, then following statements are true. What it says.
Mesela
Now, logarithm of 1 to the base b is equal to 0. So this is our first rule, first property. Logarithm of 1 to the any base, but you know the base means different than 1 and greater than 0, it is always equal to 0. And the proof is very simple if we prove this, if and only if 1 equals b to the power of 0. We know that b to the power of 0 is 1, so 1 is equal to 1, we have proof. So what I want you, ladies, just keep this as a rule in your mind. Logarithm of 1 is equal to 0. That's it. Logarithm of 1 is equal to 0. Now, logarithm of number b to the base b, it's equal to directly 1. So as we did before, 17, 17, 15, 15, 19, 19, whatever. Okay? So the proof will be b is equal to b to the power of 1. So it's clear that 1 is equal to 1. This is now 1. Now, here, the third important thing is, which we will use so much, this property, logarithm to the base b, b to the power of x equal to x. What does it mean? Logarithm to the base 2, 2 to the power of 3, result is equal to directly 3. That's it. Normally, these results comes out from this rule. Normally, we can take this in front of the logarithm, like x times logarithm b to b left. So b to b previous property, we said that 1. So x times 1 is equal to x. I mean, this could be written as 3 times log 2, 2. Log 2, 2, we know that 1, so result is 3. But as a main property, if you have this case, you can say directly result is x. Now, for a little bit difficult question, advanced level question, we use this property. What is the property? B to the power of logarithm x to b is equal to x, where x is greater than 0. Here b is base, here b is also base of the logarithm. I mean, if you have 2 to the power of logarithm to the base of 2 of 5, result is automatically is 5. So no need to make some calculations. You can do, but no need. Directly result is equal to 5. Why? This is the base, this is the base. So in the formula, this is the base, this is the base. They are equal to each other. So result is directly x. So if I ask you 7 log 14 to the base 7. What is the answer? Answer is directly 14. Am I clear till here? Do you have any question? No question yet?
no.
No. So there are four important things from the beginning. The first one is logarithm of 1 to the any base 0. Logarithm of number to the that number, I mean the base and the number are same, its result is 1. And b to the power of x, result is x. And base of logarithm and exponential number, base same, result is x.
This acting is just like so cold
Okay.
and emotionless.
Now, how can we solve this question?
Better.
Let's have a look right now, ladies. Logarithm to the base of 8. Is it possible to express 512 8 to the power of something? Let me think this. 8 to the power of 1, 8. 8 to the power of 2, 64. 8 to the power of 3. So 8 times 4, 32. 8 times 6, 48. 48 plus 3, 51. Yes, it is. That means instead of 512, I can write 8 to the power of 3. And remember the rule. What was the rule? Logarithm to the base b, b to the power of x, result is x. So same case, base is 8, base is 8, this is now x, so result is directly 3. That's it. The answer of the question is 3. Have a look one more time. If there is no question, I am passing. Okay, passing. Now, new question is this. Who can tell me direct answer? No need any calculation. What is the answer of this question?
15.2.
That's it. 15.2. Finished. We said that b logarithm to b x is equal to x. Very good. Now passing. Now it's your turn. Directly tell me what is the answer.
4.
Yes, that's it. 4. Now, do you have any question till here? No. Now, we are starting basic properties of common logarithm. What is common logarithm means? Common logarithm means base is 10. If base is 10, logarithm of x to 10, we do not write, we write log x. So when you see log x, ladies, I mean, if you don't see the base, you directly, automatically say that this is the common logarithm, which is 10. I mean, when you have square root of 5, you know that this is normally square root of 5. Since this is not given, we know that this is 2. Okay, same logic. Or when you have 7, we know that denominator is always 1. We know this. Okay, similar to this. Mute yourself, please. Mute yourself. One of you is television probably. Now, do you have any question? What is the common logarithm means? No question. Okay. Now, let me continue. Let me continue. The rules. Logarithm of 1 to the any base, we set previous slide 0. Logarithm of 10 to the base 10 is equal 1. So log 10 means, the base is not given, but we know that this is 10, and 10 to 10, which is 1, we know. Log b to b is 1. Okay, logarithm of 10 to the power of x. Since base is 10, here it's not written, so x means direct result is x. So 10 to the power of logarithm of 5 is equal to directly 5. Why? There is hidden 10 here. Base is not given, means base is 10. So common logarithm means base is 10. All the rules, what we have learned, we can use. Okay, now the question, what is the logarithm of 10,000? So this is logarithm of 10 to the power of 4. Now this is directly 4. Why directly 4? It's a property, but without that property, we know that when the base is not given, this is 10. So we have the rule that this is equal to 4. Why? We know this. Logarithm to the base b, b to the power of x is equal to x. So base is 10, base is 10, so directly we got the 4. Okay? Now, what about this? What's the answer? Quickly tell me. Quickly tell me. One of you
12.
just tell me. 12, that's it. Why? This is base is 10 not given. B, x, so result is 12. Very good. Passing. Now, log 14. What will be answer? So, what can I say for log 14?
Uh,
I have to use classical way
log
definition.
log 10. Oh, okay.
Log 14 means is equal to y. So it means that log 10 to 14 is y. So it means that 14 is 10 to y. Okay? Till here, any question? That's it. I can just say this one. Or just I have to use calculator. Sorry. This is now how can I express this as an exponential number? But just result of log 14, I have to use calculator. That's it. So what? Let us see here. How is it given in our solution? Yeah, just calculator. Can you try this, ladies, by yourself? Take your calculator. I'm taking mine also.
Yeah, I got the same answer.
Okay. Just to be sure, everyone, please try.
I also got the same answer. Yeah, I got the same answer too.
Me
Come on.
too.
So 1.146 I got. 1.146,128. So two digits if I want to write, that means 6. So it should be 1.15. Okay, good. So let us pass. What it says here, this is without calculator did? Yeah, approximation. So let's think now. Since 14 is between 10 and 100, let us look this logic, ladies. Now let's have a look. Logarithm 14, logarithm 14. Can it be less than logarithm 100, can I say? And this is greater than logarithm of 10. What do you think? Can I say or not? Is it logically? Is it possible? Yes, no?
Yeah.
So log 10, what is log 10? It's 1. What is log 100? 100 means 10 to the power of 2. That means it is 2. So my result, which is log 14, is between 1 and 2. Which number? I don't know. I mean, you can say, teacher, this is 1.2, 1.3, 1.4, 1.5, 1.6, 1.8, 1.9. Yeah, you can say all of them. It's normal. We don't know without calculator or just this simple information, we don't know. But what I know, it is clear that it is between 1 and 2. That's clear. For example, if I say logarithm of, let's say, 125, approximately, how could it be? I can say that this is between logarithm of 100 and logarithm of 1000. If I say logarithm of 100 is 2, logarithm of 1000 is 3, so that means this is between 2 and 3. So 100 and 125. So this number is so close to 100. If this is 2, let's say 2.2. Approximately, not exactly. Here 1.15, why I said, since number 14 and number 10, this is 100. If it's 100, 2. Like a ratio you may think. If it's 100, 2. If it's 10 is 1. So the difference between 100 and 10, 90 units. So for 90 units, if you have just one thing, for 14, what will be? I mean, 90, 1 unit, 14, what will be? Just cross product, 14 over 90. So 14 over 90, what will be? I don't know. It could be 0.15. If this is 0.15, you can say that 1.15. It's not important, just to give you an idea. How can you predict the logarithmic functions between from where to where? Okay, let's see now. Logarithm of negative 11. Oh my God. What is the answer? Do you have any idea?
Math error.
Yes, we said that x must be greater than 0. We said that no logarithm for negative numbers. So empty set. Let's see how is the solution here. What it says, since blah 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 undefined on the set of real numbers. Undefined, so that means there is no solution. Empty set. Okay, undefined. Good. No real solution. Okay, what about this? So it says that logarithm of 0.092. Evaluate this. So approximately what will be answer? Think a bit this. How could it be? 1.
About B.
Let's see. B. How did you do it? Can you explain to me? How did you do this?
Calculate.
Just calculator. Without calculator, how could it be?
Log 10, 0.092 is equal to y, and then we can have it in the exponential form.
Can I say this one maybe? So this number 92 times 10 to the power of negative 4, it could be, or think of it, this number 0.092, it is very close to number 1, right? It's not 1, but 1. What is the logarithm of 1? We know that it is always 0. So result must be less than 0. Am I clear? If this is 1, result is 0. The number is not equal to 1, it's less than 1, so it must be less than 0. So it directly, first of all, this cannot be, this cannot be. So there are two cases, B or D. Which one? Come on. So which one, B or D? So I may say this one, since this number is very close to number 1, if I prefer two things, this one or this one, I can prefer this one. Since if it's 1, result is 0. This is not 1. This is not 1, but it's very close to 1. So it could be this. If I guess, I can say this one. Efendim oğlum. Ver. Okay, the other slide. Bekliyorum. Okay, so here, if x is a real number, then the following statements are true. The first one is, we already said, logarithm of 1 to the any base, it's always 0. Logarithm of 1 to the any base, it's always 0. Okay, just 1 second, please. iPad'inden dene, iPad'de olmazsa buradan dene, tamam mı? Öğretmen açmamış. Öğretmen açınca iPad'ine dene, olmazsa buradan açarsın. So, now we are talking about natural logarithm. So, what is the natural logarithm? So, we talk about the common logarithm, common. What was the base is 10. Now, natural, ladies, natural means base is e. E is approximately 2.7, let's say. It's a number, okay? Now, ln1, what does it mean, ln1? ln1 means logarithm to the base e of number 1. And what we have studied till now, logarithm of 1 to the any base, it's always 0. It's always 0. ln e, what does it mean, ln? ln means natural logarithm, it means that base is e. So ln e means base is e, so we are looking to e. And remember, b to b is always 1. Logarithm of 2 to 2 is 1. Logarithm of 7 to 7 is 1. So logarithm of e to e is 1. So these two things, as we know. Now, ln e to the power of x is equal to x. ln e to the power of x is equal to x. Why? Simple. ln means this is logarithm to the base of e, e to the power of x. And so our rule says b, bx, so result is directly x. And then e to the power of ln x, we use so often, okay? E to the power of ln x directly is equal to x. The reason is this, ln means logarithm to the base of e. So x means result is x. How was the 2 log 2 5 is equal to 5? Okay, so to sum up, natural logarithm means base is e, and we use this notation ln x means that logarithm of x to the base of e. ln x means this. Okay, when the base is e, instead of log, we say ln. We read as ln, ln x. Okay, so let's go on. By the way, chat screen, let me check. Tamam, thank you, Zehra. Now, ln e to the power of 4 to 6 direct, the result is 4.6, finished. That's it. Why? Rule says ln e to the power of x is equal to x. Or you may say that ln means teacher logarithm to the base e. So the question is e to the power of 4.6, and the properties for logarithmic function, we studied that this is 4.6. That's it. Now, what about this? Directly you're supposed to say the answer. Since this is negative, we don't have the negative numbers logarithm. So ln means logarithm to the base e, negative 1.2, but this is negative, so we don't have negative number logarithm, so undefined. So it is no real solution, no real solution. Okay, what about this? Can you tell me what is the answer directly?
4.
Four.
Result is directly 4. Since this means e to the power of logarithm e to 4, and when the bases are same, result is 4. Or as a property we just memorized, e to ln x is equal to x. Okay. Now, ln 7, what can we say? Directly we should use calculator, or we can guess logarithm of 7 to the base of e. E means 2.7. E means 2.7. So if this is 2.7, say it's 3, okay? Say it approximately we are talking. If this is 3 to the power of 2, result is 2. I mean 3 to the power of 2 means 9. So your function is logarithm 3 to 7. So logarithm 3 to 1, if I say 3 to 1, which is number 3, it is 1. I mean, logarithm of 3, let me write like this. Logarithm of 3 less than logarithm of 7 less than logarithm of 9 to the base, let's say 3 to the base 3 to the base 3. So log 3 is 1. Log 9 to 3 means 9 means 3 to the power of 2. So 3 and 3, so it will be directly 2. So my result will be a number between 1 and 2. So ln 7 must be between 1 and 2. Let's say, since this is close to number 9, 1.8 it could be. Approximately 1.8, so it says 1.95. It is okay.